All right, this video is a continuation of 6.2 differential equations. This is a part 2. We are looking at 2006 AP Cal AB Form B, question number 5. Okay, so if we look at A, it says to complete the slope field for the differential equation. Anytime they say the word differential equation, we are talking about the dy dx, the first derivative. So the easiest one to see here is that when y is 1, this is going to be 0, which makes all of my slopes 0, okay? Now, when x is 0, what is cosine of 0? 1, so it'll be 1 times whatever I'm working with here. Now, do you agree that because I'm squaring this will always be positive? Okay, so that means at 0, I'm going to have something positive times 1, so they'll all be positive slopes. Okay? Now, the last thing we have left is when x is positive 1 and when x is negative 1. Okay? Because, again, this y will always be positive. Okay? Because of the squared. So, when x is a positive 1, I have cosine of positive pi. What is cosine of pi? Negative 1. So, I should have negative slopes. And then when x is negative 1, I have cosine of negative pi. Negative pi just means I go in the opposite direction in the unit circle, which still lands me at pi, so it's still negative. So my students just analyzed. I put here that this was the shape of the line, and here I meant negative. So let me draw the actual negative line. There we go. Okay, and this will give you 2 points. 1 point is for 0 slope, and then 1 point is down here for the, let me putting 1 point. Well, the other point is for the positive and negative slopes. Okay. So moving on to B, it says there is a horizontal line with equation y equals c that satisfies this differential equation. Find the value of c. Okay. So for B, I'm going to put B up here because B is literally this easy. Where do you see a horizontal line there? Good. So what do you think your answer is going to be for C? What does C equal? Yeah, you could put C equals 1 or you can put Y equals 1. That was an easy one. That's 1 point. That's why I encourage students when you're taking your AP test, no matter how crazy the question looks, read through it because sometimes there are simple points that you can get, okay? All right, part C, find the particular solution to the differential equation, and my initial condition is 1, 0. So I'm going to rewrite the question so that I can scroll down. All right. All right. So the cosine holds the x, so he's going to have to stay on the right side. And then this y minus 1 squared has the y inside, so that entire thing is going to have to move to the left. Okay? So I'm going to say 1 over y minus 1 squared dy equals cosine of pi x dx. Okay? There goes your first point for separating the variables. Next, I need to integrate both sides. Be very careful with any possible u subs that could be going on. Okay? Remember, this is an exponent of 2, which means I'm going to be bringing it up with a negative 2. Okay? Let me set up my u subs though. Right. So on my left side, my inside is y minus 1. Derivative of that is 1, so I'm not missing anything. I'm good here. On the left side, my inside is pi x. Derivative of that is pi. I've got a problem. I'm missing a pi. So I need to multiply by 1 over pi. Okay? So now this is going to change to the integral of y minus 1 to the negative second. Antiderivative here is add 1 and divide by your new value. So I have y minus 1 to the negative first, divided by negative 1. On this side, I have 1 over pi. What is the antiderivative of cosine? Good, it's sine. Keep your u in there. And then I have my plus c. So for this question, if I think about isolating y, it may look a little crazy. I'm going to start plugging in my ordered pair to solve for c. I'm going to change this to a negative 1 over y minus 1. But I'm going to plug in my y. And now I'm plugging in my x. Okay. Here on this left side, I just get 1. And then what is sine of pi? 0. So we found our c. Okay. All right, so the next thing I'm going to show you is kind of like a tip. When I have too many fractions, things might get a little complicated. An easy way to get rid of having this fraction right here where I'm pointing at is to multiply both sides by pi. Okay? This is one of just those useful tips. Okay? So I'm going to have negative pi over y minus 1 equals, the pi being multiplied here will cancel it out. And then here, 1 times pi is just pi. Okay? Now, the next thing we're going to do, so now, like you guys saw in the last question about flipping a fraction on each side, do you see that I have one fraction on the left? How can I write the right side so that it looks like one fraction? Exactly, over 1. If I write that over 1, now I can flip both sides and have the y in the numerator. Okay?
So wait, like, have I been able to always do that in math?
Yes, this has always been allowed. As long as there is one fraction on each side, you have been allowed to do that. So now I can multiply this negative pi over to the other side and then just add the 1. Okay? I'm going to come up here to have some more room. And now you are done. That is your particular solution. Okay? So again, 1 point goes to the separation of variables all the way up here. 2 points to the antiderivative. 1 for each side. 1 point for the c. 1 point for plugging in your initial condition. Okay, which happened there and there. 1 point for your final answer. 1, 2, 3, 4, and then 5. I got the separation of variable. I have the 2 for the antiderivative. I have the constant. Oh, right here. 1, 2, 3, 4, 5, and 6. All right, so let's look at this question. Consider the differential equation dy dx. Part A says find the solution for y with this initial condition. Okay, so A is our differential equation. It's our separation of variables. Okay, so I have dy dx is 3x squared over e to the 2y. Now that y is stuck in the exponent of e, so I am going to have to move that entire denominator. So this entire thing is going to go multiplied over, and this entire thing is going to go multiplied over. Okay. Next, I need to integrate both sides. This right side is a nice, easy reverse power rule, but on this right side, there is something more than just a variable in the exponent, so you need to be careful with your u sub. My u would be 2y, which means my u prime would be 2. You see how I'm missing that? So if I'm missing this 2, I need to put a 1/2 in the front. Okay? So I have 1/2, and the antiderivative of e to anything is just e raised to that same exponent, okay? And then here, reverse power rule, I just end up with x cubed plus c, okay? So we've done 2 times where I solved for c first. I'm going to do this one solving for y first. I'm going to multiply, well, divide this 1/2, which is like multiplying a 2 over. Okay, now technically I multiplied that 2 to the c also, but 2 times a constant is still a constant. Okay, so now what can I do to get rid of that e and start getting that y out? Good, I can ln both sides. Notice that I ln this entire right side. Okay, so this cancels and I have 2y equals ln of 2x cubed plus c. Okay, now if I divide by 2, I can say y equals 1/2 ln of 2x squared plus c. Okay, so I'm going to come up here just to have some more room. I'm going to plug in my ordered pair, which is 0, 1/2. So I can say 1/2 equals 1/2 ln of 2 times 0 squared plus c. Okay? All right, my students, just notice that I put a squared instead of a cubed. Okay? 0 cubed is 0, and 0 times 2 is 0, and 0 plus c is just c. Sorry for that interruption of our bell. So I have 1/2 equals 1/2 ln of c. Okay? I can divide this 1/2 over, which leaves me with 1 equals ln of c. How do I get that ln out of there so I can get c by itself? Good. E both sides. This cancels. So I have that C equals e to the first power. Okay? Now last step is just to plug it into my equation. Y equals half ln of 2x cubed plus e. Okay? And that is it for part A. This is also 6 points. 1 for the separation. 2 points for the antiderivative. 1 for plugging in your initial condition. 1 for your constant. And 1 for isolating y. Okay? So now, B says find the domain and range of the function f found in part A. It's funny, this question almost has nothing to do with calculus. Okay? Here is the function that I found. What is the graph of ln? So the graph of ln has an asymptote at 0 and then shoots off on the right side for the positive numbers. Okay? So look at the equation we have. Multiplying half to the ln is just going to shrink this. Okay? I do not have a number on the outside being added or subtracted, so it's not going to move up or down. But I do have something happening on the inside. Okay? So whatever I plug into x has to be that this entire thing is still positive. Remember how when we had ln's, we would put the absolute value because it had to be positive? So let's do one thing at a time. The easiest one to see is range. This is only going to move side to side. What will my range continue being? Exactly. All real numbers. Negative infinity to positive infinity. Now for domain, remember that the inside of an ln always has to be positive. So set yourself up a little inequality to mean positive. Okay? And once you isolate x, you will have your statement for the domain. Okay? So your domain is that x's have to be greater than the cube root of negative half of e. Okay? And here you would score 3 points. 1 for the range, which was a lot simpler. 1 for setting up your inequality and understanding that concept. And then 1 for your final answer for a domain. Okay?